Hello, today we'll look at reflections in the coordinate plane, and I do want to warn that this is a topic that takes visualization and looking and taking note of the rules. Okay, so I've written a lot of the rules here. So these are the rules that if you don't have them written down somewhere, that you should write them down. Also, kind of visually being able to say, well, this is what this should look like. That's also very important as well. So like I said, here are a few of the rules that you definitely want to take into consideration. So let's do an example. It says, what is the ordered pair for B prime? And that's just how you really denote a transformation at the reflection of the y-axis. So here's my y-axis. This is my y-axis. And here's point B. To reflect across the y-axis means to go to this side. So that means that my x value is going to stay, my y value will stay the same, but my x value is going to change. So the current value of B is 3, 2. So that's what B is. But I want to know what B after my transformation is. And so when I transform it, my x value will change. So that's going to be -3, 2. All right, then it says, what is the ordered pair for f at the reflection of the x-axis? So here's my f, and my value for f is at 4, 5. This time I want to reflect it against this x-axis. So which value is going to have to change? If I want to change it to my x-axis, that means my y value is going to have to change. So my new transformed f is going to keep the same x value, but my y value is going to change to -5. So the y value changes. All right, then it says point C is graphed at -4, -10. What is the image of C after reflection over the y-axis and a translation of -7, -12? So I have this point, it's graphed at -4, -10. If I reflect it over the y-axis, I hope you remember that the y-axis, a reflection means, so my C is at -4, -10. Reflection of the y-axis means that my x-axis is going to change. So I'm not going to put C prime yet because actually I need to reflect it first, then translate. So that means that if my y-axis, I'm going to change this to a +4, and this is still going to stay a -10. That's going over the y. So again, if I have my graph here, I want to reflect it against this y-axis. I want to move it from here to here. So that means that nothing is happening to my y, but my x is changing the sign. And so then the translation, this means that I'm just going to add these values to it. So I'm going to have 4 plus -7 and -10 plus -12. So my C translated would be -3, -22. All right, the next one, it says point P is graphed at -3, 7. What is the image of W after reflection of the x-axis? So I have -3, 7, and it's followed by a translation of -2, 10. Can't forget that part. So again, here's my graph. This is my x-axis. If I have a point at -3, 7, if I want to go across, my x value will be staying the same, but my y is going to change. So that's going to give me -3, -7. And I need to translate it. So my w prime is going to give me -3 plus -2 and -7 plus 10, which gives me -5, 3. All right, the next one, it says, at the reflection over the line y equals x, C prime is plotted at 8, 11. What is the original location of point C? So again, if I draw it out and it's at 8, let's say this is 8, 11 is right here. The line, the line y equals x looks something like this, and I don't know if this point is on this side or this side, but regardless, we know that when we switch the x and the y, I'm just going to flip those around. So that means that I get 11, 8 instead. And so it's going to come over to 11, 8 instead. So that's the line that it flipped over. And so this would be the C original. And I know that this works because if I reflect it back over the line, I should get this thing again, right? Which is 8, 11. All right, it says after reflection over the y-axis, 0, 4 is the image of point L. What is the original location? So again, I have my graph here. My axis is here. This is the y-axis. 0, 4 is right here. Well, to reflect that, I can't really do anything, right? Because how can I reflect this over the y-axis? This is the y-axis. So this is going to give me 0, 4. And when I change it over the y-axis, the thing that I'm changing is the x, and the x is 0. All right, so now this one is a little where I have to look at different rotations and reflections, and this is almost similar to what we have in the on some of your tests and quizzes. It says what set of reflections could carry hexagon A, B, C, D, E, F onto itself, and they give you the coordinate points, and I plotted the coordinate points here. I didn't connect the lines, but let's say I did. They were there. This is what it looks like, and I want to do these reflections such that they come right back onto each other. Well, the way that I do this, because I'm not a visual person. I have to use the rules. I will admit I'm the type of person who has to use the rules. So what I do is I take one point and I perform those operations to see if it comes back onto itself. So let's do that. So the first one, so the point that I chose was D. I chose -2, -3. And so the first one for A, it reflects over the x-axis. So when reflected over the x-axis, I get -2, -3, because the only thing that changes is the y value, right? It changes the sign. And then I switch it over I've switched to y equals x. So then that's going to go to -3, -2. Then I'm going to go to switch the x-axis. I reflect it over the x-axis. And so when I do that, I get -3, +2. And then I'm going to switch it back, y equals x. So it's going to give me 2, -3. Okay, so that does not get me back to that -2, 3. So this one is out. I wish I knew a quicker, easier way, guys, but this is the way that I know. The next one, using the same point, -2, -3, going over the y-axis. It's going to change to, let me erase this so we don't get confused. All right. So going over the y-axis, it's going to give me my x will change to positive. It's going to change signs. So it's going to give me 2, 3. Then I go over the y-axis. I'm sorry, go over the x-axis. So the x-axis, this time my y will change. So it's going to give me 2, -3. And then I'm going to go back over the y-axis. When I y-axis, my x changes. So it's going to give me -2, -3. And again, this does not equate to this, so it's not B. Let's do C now. Some of you might be visual learners and you can see directly what happens when you start flipping it around. That's just not the case for me. So it will be hard for me to show you in that way. All right. The next one. So first I'm going to flip it over the x-axis. So when I flip it over the x-axis, so that's going to be -2, -3. So the only thing that changes is my y value. Then I'm going to flip it over the y-axis. So that's going to become +2, -3. Okay, so my x value changes. When I flip it over my y value again, my x value change to -2, -3, which is not the original. So looks like it's going to be D. So I know some of you all will be quick to say, okay, well, the answer is D. Hopefully we're right. Let's check ourselves though. Let's verify that we're correct. So first, y equals x. So I'm going to flip this around to 3, -2. Then I'm going to reverse it over the x-axis when I do that. My y changes, so that's going to be 3, +2. Then I'm going to flip it back over the y equals x. So that's going to give me 2, 3. Then I'm going to flip over the y-axis. That means my x changes, so that's going to be -2, 3. Thank goodness it worked out. So D is the correct solution. And I hope that these examples help, and if not, they help for you to see how you can apply multiple transformations to each other.